Okay. Maintain. Tama ang ginagawa mo. Alright. Now let's go for a 360 overhead approach. Kap? Ano ba yung 360 overhead approach? So you're telling me, nalipad ka nang hindi mo alam?
Shucks! Kapag hindi ko ito nasagot, mararap ako. Ano nga ulit yun?
In the aviation industry, where various professionals work together to ensure safe and efficient operations, communication plays a vital role. Every second counts and every decision matters. A single misunderstanding or incorrect decision can lead to serious consequences, including potential collisions or airspace violations. As pilots, we carry the responsibility of ensuring the safety of passengers, crew, and aircraft. Here at WCC, student pilots are trained to become skilled, disciplined, and safety-conscious aviators. We practice a wide range of procedures to sharpen our flying skills.
But flying isn't just about controlling the aircraft. These procedures also involve standard radio communication to ensure that other aircraft and air traffic control are aware of your identification, position, and intentions.
Good day, aviators! Today we'll be discussing the 360-degree overhead approach. On to you, Salvi.
The 360 overhead approach is a visual landing technique where an aircraft flies over the runway, then makes a 360-degree descending turn to align with the final approach. It's commonly used in no-power or emergency situations to maintain control and ensure a safe, accurate landing. It is also known as a power-off accuracy approach, which are landings where the pilot glides to the runway with the engine at idle while following a planned flight path. The goal is to touch down safely and accurately, landing within 200 feet past a specific mark on the runway. This helps pilots practice good judgment and technique so they can land the plane safely even if the engine fails. If you want further information, look up the FAA Airplane Flying Handbook Chapter 8. So now, how do we do a 360 overhead approach? Step 1. Fly overhead the station at the altitude of the circuit pattern plus 500 feet vertical clearance, which is 1,200 feet. Configure your plane for landing, but no flaps yet. Once established overhead the aiming point, commence the 360 overhead approach by Step 2. Set throttle to idle. Pitch for the best gliding speed, which will give you the best shot at making it to the runway. And remember, don't fly too fast or too slow, as it risks your gliding distance. Step 3. Apply a medium or slightly steeper bank turn in the desired direction so as to arrive at the downwind key position, also known as the inner downwind. In this case, in runway 17, we will turn clockwise, as our turn should be inside the traffic pattern we used that time. Step 4. After reaching and passing the downwind key position, the turn can be continued to arrive at the base leg key position. Step 5. Flaps may be used at this position as necessary, but no full flaps yet. Full flaps should not be used until established on the final approach. Maintain the best gliding speed all the way. Step 6. When landing is assured, apply full flaps if needed. Establish your final approach speed and trim. The ACS, or Airman Certification Standards, requires the following for maneuver completion. Touchdown on or within 200 feet from the specified touchdown point with no side drift, minimum float, and on the center line of the runway. Now that you know how it's done, let's have our pilots Stefan and Chester using the Tecnam P2002JF to demonstrate the radio communication of commencing a 360 overhead approach.
London Radio, RPC 1972 at ramp. Good morning. RPC 1972, Binalon Radio, good morning, go ahead. Binalon Radio, RPC 1972 at ramp. Request for engine start. RPC 1972, Binalon Radio, runway 17 news, altimeter setting 29.75, wind from 150 at 5 knots, cleared for engine startup. Runway 17 in use, altimeter setting 29.75, wind from 150 to 5 knots. Cleared for engine startup. Binalon radio, RPC 1972 at ramp. Request a taxi to run up area for run-up checks. RPC 1972, Binalon radio, taxi to run up. Taxi to run up area, RPC 1972. Binalon radio, RPC 1972 at run up area. Request a taxi to holding point, runway 17. RPC 1972, Binalon radio, taxi to holding point, runway 17. Taxi to holding point, runway 17, RPC 1972. Binalon radio, RPC 1972 at holding point, runway 17, request to enter the active runway and line up. RPC 1972, Binalon radio, line up runway 17. Line up runway 17, RPC 1972. Binalon radio, RPC 1972 at runway 17, ready for departure. RPC 1972, Binalon radio, wind calm, you may take off runway 17. Take off runway 17, RPC 1972.
Binalon radio, RPC 1972, airborne runway 17. Request to climb 1,200 feet for a possible 360 overhead approach.
RPC 1972, Binalon radio, report high base runway 17.
Will report high base, runway 17, RPC 1972. Binalon radio, RPC 1972 at high base, runway 17, for 360 overhead approach.
RPC 1972, Binalon radio, report commencing.
Will report commencing, RPC 1972. Binalon radio, RPC 1972, commencing 360 overhead approach.
RPC 1972, Binalon radio, continue 360 overhead approach.
Will continue 360 overhead approach, RPC 1972. Binalon radio, RPC 1972, cleared off the active, request to taxi back to ramp and will be terminating flight plan.
RPC 1972, Binalon radio, taxi back to ramp.
Taxi back to ramp, RPC 1972. Binalon radio, RPC 1972 at ramp, request to commence engine shutdown.
RPC 1972, Binalon radio, cleared for engine shutdown, good day.
Cleared for engine shutdown, RPC 1972, good day.
That's all, aviators! I hope you learned something today about the 360 overhead approach and the importance of aviation communication. And remember, aviate, navigate, and communicate.
Kuya, hindi mo ba maalala kung ano yung 360 overhead approach?
Ay,